The automotive industry is undergoing the most comprehensive transformation in its history towards e-mobility. The increasing spread of battery electric vehicles leads to questions about the ecological footprint of vehicle batteries, as well as raw material security and availability, and thus the competitiveness of German and European industries. The heart of electric vehicles is the battery. It contains valuable raw materials which must be recycled to use finite resources efficiently. Transitioning from a linear throwaway society to a circular economy is crucial to meet societal, economic and environmental demands. This is where the Circle research project, funded by the German Federal Ministry of Education and Research, comes in, developing strategies and processes for the circular production of highly integrated electromobility components. As a project partner, Liebherr-Verzahntechnik GmbH supplied a system for the automated disassembly of high-voltage battery systems to the Open Hybrid Lab Factory Research Campus in Wolfsburg. Processes need to be automated to recycle batteries in large quantities. This starts with opening the battery system, which is still done manually. As part of the Circle project, the teams developed and programmed a robot cell to open the high-voltage batteries. From Kempten in the Allgäu region, Liebherr supplies the global automotive industry with high-quality automation systems and technology solutions. The robot cell for the automated disassembly was put into operation for the first time at the Liebherr Automation Systems Tech Center, and the process sequence was validated. Afterwards, the robot cell was relocated to the Wolfsburg Research Campus. Liebherr will continue to supervise the project at the research campus and accompany test series. The results and experiences from this project contribute to design future battery systems in a disassembly-friendly manner. Automated disassembly processes not only ensure a high recycling rate, but also prioritize the health and safety of workers by minimizing risks associated with high voltage, hazardous substances and fire hazards. With the transition to electric mobility, closing loops and minimizing a vehicle's environmental footprint across its entire life cycle are becoming increasingly crucial. The key to achieving a more sustainable mobility lies in the consistent shift towards a circular economy.